20 years ago, penetrations in smoke and fire barriers were almost never sealed. Over the last decade, however, this has changed and penetrations are now sealed routinely in most commercial construction. While such progress has gone a long way toward ensuring compartmentation, these advances in life safety have not occurred equally for all openings. To seal penetrations while ignoring other openings in smoke and fire barriers provides little more than a false sense of security. Yet, construction joints, the largest and most common gaps of all, are the most frequently overlooked openings in construction. This video provides an overview of the issues surrounding joints, gaps, and blank openings in fire barriers and the products needed to fire stop them properly. Now, it does not provide a how-to or hands-on approach, as this is best done on-site. Have you ever encountered a hole that seems to have no obvious purpose? This can be good news if you're pulling cable and need a clear path through a wall or floor. But it is bad news when discovered by an authority having jurisdiction or during a survey, or worse, in an actual fire. Occasionally, these holes are planned and intentionally cored or sleeved for future use.
More often than not, however, obsolete equipment or building services were removed, leaving behind empty holes that are often forgotten or ignored.
When this happens in a rated wall or floor, it must be sealed or serious code violations are created. The good news is that blank openings can often be sealed inexpensively if you consider two issues: the size of the opening and the need for future access. Either way, blank openings are among the simplest conditions in need of fire stopping. Because smaller openings tend to be quicker and easier to seal than larger ones, the simplest and most economical remedy is usually pillows, putty, or sealant over mineral wool. In larger wall openings, however, the best remedy becomes less obvious. In some cases, a simple scab patch of 5/8 inch type X gypsum board in a framed opening can be attractive because the materials are readily available and the work is simple. But future access is difficult and the work is dusty, noisy, and difficult to perform in confined spaces. Fire stop pillows cost a bit more, but require very little labor. They work well in confined spaces where access is difficult and can be installed without creating a lot of dust or noise. Although the initial cost may be higher, when future access is expected, pillows nearly always offer the most economical remedy. Construction joints are all around us and are necessary parts of modern building. The two most common types are those that separate different structures, such as where a new wing meets an existing building, and those that are engineered into a design to accommodate movement. Like penetrations and blank openings, when joints occur in a fire or smoke compartment, they must be sealed. In some cases, joints can be more critical even than through penetrations. Consider the joint at the top of a fire-rated wall. Where do you suppose toxic smoke and superheated gases accumulate in their greatest concentration? It's at the ceiling, right where this joint occurs. Unfortunately, as a fire progresses on one side of a fire barrier, a pressure differential builds between the two sides. This differential is also greatest at the ceiling and forces the products of combustion quickly through this joint unless it's sealed. But simply being sealed may not be enough. These joints also expand and contract, and unless the seal can handle the movement, the fire barrier will fail. Most joints are subjected to movement and are referred to as being dynamic. Far less common are static joints, which don't move at all. Now, interior and exterior walls and floors all experience a wide variety of forces that may cause them to move. Floors are subjected to deflection as occupant loads change, and similarly, roof decks may be subjected to wind shear or snow loading. To further complicate things, walls and floors may be subjected to settling, seismic movement, and vibration. Likewise, exterior walls are subjected to wind loading as well as thermal expansion and contraction from both seasonal and daily heating and cooling cycles. As these walls and floors move, the joints where they intersect open and close, and fire-stop fill materials must be able to accommodate that movement, or they'll be damaged and fall out, jeopardizing the fire barrier. Understanding how to properly seal these linear openings begins with understanding the 5 basic types of joints. The first is a wall-to-wall joint, such as a vertical saw cut in a block wall, or a gap where 2 walls intersect. The next is a floor-to-floor joint, such as the expansion joints most commonly seen in parking garages. The third, a wall-to-floor joint, is by far the most common and is usually referred to as the head-of-wall or partition head joint. The fourth is a floor-to-wall joint, which is where a fire-rated floor slab meets a rated wall. A common example of this is where a shaft penetrates a slab. The last type of joint is a slab-edge curtain wall joint, which is where a fire-rated floor slab meets the exterior non-rated building skin, often called the safing slot or the curtain wall joint. The seal in this opening technically doesn't qualify as fire stop since the curtain wall has no fire rating. But it still has to be sealed, and the proper name is the perimeter fire barrier system. Now, we won't discuss these joints in this video, as this work is primarily done during new construction and major renovation rather than during maintenance. Because nearly all joints move, the 3 product types that are used in linear applications are all flexible or elastomeric, although to varying degrees. One is a spray-applied coating, and 2 are gun-grade sealants. The most popular products used in joints are spray-applied acrylic coatings that cure into a thin rubbery film. When cured and bonded to either side of a joint, this membrane flexes with the extension and compression of the joint. Because they are spray-applied, production rates are high, making sprays very economical when sealing long linear runs. The coating is generally sprayed to a wet thickness of around 1/8 of an inch, although this varies somewhat by manufacturer. Where access is more restricted, or when shorter runs need to be sealed, a gun-grade sealant applied from a caulk gun may be preferable. There are 2 types, silicone and latex. Both are caulked into a joint generally to a depth of around 1/2 or 5/8 of an inch. This too varies somewhat by manufacturer, so take care to check with the UL system before installing. For years, silicone sealants were the only option for joints in fire-resistive construction, and they dominated this segment of the fire stop market. They're durable, strong, and bond well to most common building materials, can take tremendous movement, and have excellent chemical resistance. They cure quickly, and most have virtually no odor. Now, silicones, however, do have some limitations that you should be aware of. They're not paintable, and they require solvents rather than water for cleanup. They also tend to be more expensive, have a short shelf life, and are difficult to apply. Now, in general, latex caulk is not terribly flexible and can't handle the dynamic cycling of joint movement. However, new elastomeric acrylic latex fire stop sealants with excellent movement abilities have been developed for joints and are growing rapidly in popularity. They tend to be very economical and are much easier to install than silicones because they can be cleaned up with water, are paintable, and have no more of an odor than latex paint. While they are flexible and can take movement very well, they tend to be slightly inferior to silicones in performance. Regardless which material is selected for use in joints, they all generally require mineral wool, which stops the transmission of heat through the opening. The fire stop seal, by contrast, simply stops smoke and gases. In rare instances, some UL systems permit fiberglass insulation or spray-applied fireproofing to be substituted for mineral wool. But in most cases, the mineral wool must be compressed to a specific pound density and packed firmly into the opening. In a floor, the wool is first packed firmly into the joint, and then the fire stop sealant is applied only on one side, over the wool from above. While the wool is an essential component of the system, the coating is equally critical. In a fire, the binders in the mineral wool break down, causing the wool itself to break down. This permits butt seams to open where sections are spliced together, permitting toxic smoke, superheated gases, and flames to spread vertically through the joint. Therefore, without a good seal above, mineral wool alone will not work. In walls, a seal must be applied symmetrically over the wool on both sides of the wall. In a fire, the seal on the hot side of the wall becomes sacrificial, but the wool stops the transmission of heat, and the seal on the cold side stops the smoke. Therefore, it is important to remember that not only is the mineral wool packing a critical component of the fire stop system, but walls must be sealed symmetrically as well. Because the seal is as critical as the packing material, it is important to avoid the three causes of sealant failure. If a joint is contaminated, such as with oils or dust, then adhesive failure will result when the joint moves. Good prep work can easily prevent this. Even when good adhesion is achieved, joints sometimes still fail. When the sealant tears apart, we call this cohesive failure, which results from excessive joint movement or improper sealant selection. One common example of cohesive failure happens when a sealant bonds to all three sides of a joint. This is known as three-sided adhesion. The most common example of three-sided adhesion is in a head-of-wall joint where a bead of sealant might be bonded to the steel deck on top, the top track on the side, and the cut edge of the gypsum board on the bottom. When adhesion occurs only on two sides, the joint moves freely and the sealant moves with it. But when the sealant bonds to a third side in a joint, the sealant becomes glued shut and will be torn apart when the joint opens. The way to eliminate three-sided adhesion is to install a bond breaker like backer rod or a bond breaker tape before installing the sealant. The final cause of sealant failure really isn't failure of the sealant at all, but of the surface that it's bonded to. When a fire stop seal is bonded to a wall or floor that's damaged or weak, the seal will hold, but will pull the substrate apart when the joint moves. This is called substrate failure. A common example of substrate failure is old spalling concrete. Another example is in joints that intersect structural steel or pan decking that is coated with a spray-applied fireproof coating, which has a very weak cohesive strength. When a fire stop material is bonded to this spray-applied fireproofing and the joint opens, the fire stop may pull the fireproofing right off the steel. This is a very dangerous condition because now the fire stop in the joint has failed and the steel has lost its thermal protection. Whenever installing fire stop against either spray-applied fireproofing or structural penetrations such as I-beams, be sure to consult the fire stop manufacturer's UL system information to confirm compatibility. While the mechanics of installing fire stop materials into a joint may be simple, choosing the appropriate product and UL system is a bit more complex. In either case, understanding the basics of joint design simplifies the process and helps to ensure a proper installation.